So, अरे यार, guys, एक minute. I just disconnected this thing. No, let me connect it again. This thing, so please write heading. Explanation of diffraction by Huygens principle. So, guys, suppose I have this, a slit, but the diameter of the slit is large here. So, suppose if this is case number one, the object or obstacle's size is large as compared to wavelength of light. So, guys, see what will happen. Suppose if I have, this case one. So, guys, here the obstacle or the slit, whatever it is, it has a size very large as compared to this thing. So, if I have plane wave fronts which are entering like this, suppose control C, control V, control V. So, guys, can you see these plane wave fronts like, right? So, these plane wave fronts, they are coming towards this particular thing. If I try to draw the light rays will look like this. And so on, right? So the light rays look like this, yes or no? So let us assume this light ray, guys, let us assume these light rays. Can you see these light rays, the black ones which we have just drawn? The green are basically the plane wave front. And can you see these light rays? These light rays, let's say 1, 2, 3, 4, 5, 6, 7, and 8. Will they get blocked? Yes or no? Because of the obstacle present over here, these light rays 1, 2, and 7, 8 will get blocked, right? Hello?
Yes.
है. Let's talk about these light rays which are let's say this, and let's say here we have our screen diagram. देख लो कितना perfect बन रहा है. So you can see light rays number 1, 2, 7 and 8 get blocked. Light rays number 4 and 5 they pass as it is without any deviation, right? But what happens to light rays number 3 and number 6? What happens to light rays number 3 and number 6? Can you see these light rays they come across this particular corners, right? So what will happen to these light rays? They will they will bend.
bend.
तो ये थोड़े से बेंडिंग दिखा दी मैंने. So can you see guys, light rays number 3 and light rays number 6 they bend across these corners. This phenomena of bending is basically called as what? Diffraction. Can you see these rays didn't diffract, but these light rays they bent from their original path. Yes or no? Yes or no guys? समझ में आ रहा है थोड़ा बहुत? 1 2 3 4. Oh sorry, 1 2. Shall I write ki which rays got blocked, or ki you understood this, right? So only rays which passes through the edge of the object bend into the shadow region due to diffraction. So sir, how will you explain it using Huygens principle? Guys, can you see there are various secondary sources over here? Can you see various secondary sources are there, right? So you can say this particular thing, only those secondary sources, suppose these secondary sources will be, let's say after one wavefront is falling over here, and exactly let me, yeah. So guys, can you see this wavefront? This is the incident wavefront, right?
Yes.
So only those points on the incident wavefront, delete कर देता हूँ ये वाला. So only those points on the incident wavefront, जैसे for example this, all these points they will be acting as secondary sources, right? All these points on this incident wavefront will be acting as secondary sources, but can you see over here, only those secondary sources will be producing secondary wavelets which are in the open region of the slit. So basically this won't be able to produce any secondary wavelet, this won't be able to produce any secondary wavelet, this will also produce a little bit, but uska अपन देखेंगे. This will produce secondary wavelets. Let me draw them with some other color. Which color shall I choose? Let's choose pink. So these wavelets, can you see? These are the secondary wavelets produced by this source. So please remember, only the rays passes through the bend into the shadow region, and only those secondary sources on incident wavefront must be producing secondary wavelets which are in the open region of the slit, right? Is this clear guys? इतना समझ में आया? Yes or no? Guys, do you understand this particular thing? Itna much? Now
Yes.
what will happen to these wavelets, these second wavelets from these source? Can you see those which were in the open region were basically what? Producing complete wavefronts like this, complete wavelets like this. But those which are at the corners, can you see the one which are at the corner, they will be only producing this much wavelength, right? They will be only producing this much wavelets, right? So can you see the wavelets produced by the one at the edges, they are having a little bit less intensity because they are not producing wavelets in all possible directions, right? So all the secondary sources which are at the edges of the slit will be producing wavelets of comparably less intensity. Why, guys? Why? As the size of the wavefront gets reduced. Yes or no? So that's why they have very less intensity, and that's why this region looks completely bright, whereas this region looks like a little bit lesser intensity. The intensity keeps on decreasing, and here it becomes completely dark. Are you getting my point? Yes or no? Can you see over here in this case when the size is almost big, note most of the light rays or most of the wavefront follows rectilinear propagation. Yes or no? Can you see the rays which
Yes.
are from 4, 5, and there will be millions of rays in this. So most of the rays will form a rectilinear propagation. Only some of the rays will be bending from the edges, and most of the rays will be blocked. Right? Are you understanding this part? Case one, clear? So when the slit size is large, most of the wavefront they follow like rectilinear propagation. But case number two, when the size of the object or obstacle or whatever slit is, size of object or obstacle is comparable to the wavelength of light. यहाँ पे diffraction phenomena will become prominent to wavelength of light. Then what will happen, guys? Let me just copy and paste the diagram again. Control C, Control V, Control. So guys, can you see here the slit? Here the slit size is very small. Let me make it a little bigger. So now what will happen, guys? Again, can anyone tell me what will happen in this case? Can you see most of the light rays will get blocked? Most of the light rays will get blocked. Guys, you need to draw it exactly like मैं तो बहुत अच्छे से draw करने की कोशिश कर रहा हूँ because I guess last time. So everyone can see these plane wavefronts, right? The green one is basically the plane wavefronts, and the black one are basically the rays. So can you see the light rays were going like this? Many light rays were going like this, right? Yes or no? Most of them were getting blocked, but can you see only those rays which will be passing through that small slit will basically what happen? They will fall over here, right? So there are multiple sources, multiple secondary sources which I can choose. Let me choose one in the between as well. So can you see there are many sources which are there on the secondary source. Most of the we can say this almost ऐसा नहीं, most of the secondary surface secondary surface secondary sources, most of the secondary sources don't produce the secondary wavelets as they get blocked. Only few wavelets are allowed. Wavelets are allowed. Now these sources, only few are there, right? Now what will happen to these sources? These sources will produce light of equal intensity, although very less, because most of the intensity will be blocked, right? Most of the light is blocked. So although these sources, s let's say, they will produce intensity in, can you see, the jitna zyada size you will decrease, more it will bend in that particular direction. Yes or no? Can you see these rays which bent mostly? And can you see, if I draw the secondary wavefronts now, these secondary wavefronts look like this. Are you getting my point? These wavefronts which were initially plain now become like this, right? So what happened to the light rays? The light rays, they only go in these particular directions, and here you get a, on the screen, what do you get? You form a pattern on the screen. That pattern is basically called as diffraction pattern. Is it clear? So only few wavelets are allowed. Now these secondary sources produce light of equal intensities, although very less, as compared to incident light, although very less as compared to incident light, but in all the direction of the screen. So here basically what happens is rectilinear propagation followed. Is the rectilinear propagation followed here? If rectilinear propagation would have been followed, so you would have got only a small dot like this, right? So basically, since the intensity is getting spreaded all over the screen, so hence you cannot say the ray is behaving as a particle anymore. You can say the ray is behaving as a, so here the light ray, or here the light doesn't follow particle nature, or basically rectilinear propagation. So this phenomena is considered under wave nature. Can you see, guys? Under the wave nature, you were able to explain it, but under the particle nature, you were not able to explain it, right? So understood, using wavefront propagation, using the concept of wavefronts, we explained what? We explained what? Guys, hello. We explained what are diffraction phenomena. Is it clear? Since it acts as a secondary source, so secondary source, it acts as a point source, right? And we know what happens in the case of point source. Spherical wavefronts get created, right? So those spherical wavefronts, they superpose and form a pattern over here. This pattern is basically called as diffraction pattern and all. So we'll be studying that particular thing. Any doubt in that particular thing? How did we explain it using Huygens principle? Guys, any doubt? Now the next heading is basically types of diffraction. There are two types of diffraction analysis. है First diffraction analysis is basically called as Fresnel's diffraction. And the second diffraction is called as the Fraunhofer's डिफ्रैक्शन। दोनों साइंटिस्ट के नाम है ना, फ्रेस्नेल एंड फ्राउनहोफर, बोथ वर साइंटिस्ट।
So,
हाँ जी,
so could you scroll up?
श्योर। कितना है आप?
So yes, sir, here the last paragraph.
ओके। गेट गेट।
Yes, so you can scroll down.
चल, so now let's see what is basically Fresnel's diffraction and Fraunhofer's diffraction. There are, these two types of diffraction, which we are going to study. So basically, I'll draw a table. Now, what is Fresnel diffraction? You'll write when diffraction of light is analyzed from the diffracting device, dif- diffracting लिख लो, ज़्यादा better लगेगा। From the diffracting device from a finite distance. ये point is very important. From a finite distance, then it is studied as under Fresnel's diffraction. Under Fresnel's diffraction. For example, suppose this is our single slit.
Scroll a little up. Yes, sir.
So guys, here there is, the source which is producing the light rays, or which is producing the wavefronts. But these wavefronts are, when the source is at a finite distance, will these wavefronts be plane, or will this wavefront be spherical? The wavefronts in these case, will they be plane or will they be spherical? Yes or
Spherical.
no? So can you see what is the difference in this case? These incident wavefronts are not plane, they are basically spherical, right? And due to this thing, what will happen? The light ray will again, these sources will be forming, and they will form a pattern, on the screen. One second. So light ray will bend like this and this on this screen and form a pattern. So can you see these two distances? What is d1? D1 is basically the distance of the source from the slit, and what is d2? The distance of the screen from the slit. Here d1 and d2 are basically finite distances. So that type of diffraction pattern which is obtained is basically Fresnel's diffraction. Here the second type of diffraction is when the diffraction of light So when the diffraction of light is analyzed from the diffracting device from an infinite distance, from infinite distance, then it is studied under Fraunhofer's diffraction. You don't have Fresnel's diffraction in your 12th grade syllabus. You have Fraunhofer's diffraction. है ना, because it's simpler, मतलब comparatively, obviously, है ना. So basically, what will happen in the case of Fraunhofer's diffraction, guys? Control C. Ab here the differences will be what? The source will be at infinity. So basically, D1 is also infinity. D1 and D2 both are tending to infinity in this case. है ना? So if source is at infinity, what kind of wavefront, what kind of waves will be generated from this thing? What kind of rays will be generated? Will parallel rays will be there, right?
Yeah.
So in this case, parallel light rays will be coming, and what will be the wavefront shape?
Plane wavefront.
Plane wavefront to plane wavefront drawn like this, right? What will happen when these plane wavefront will fall on this particular thing? Again, it will have, some diffraction pattern. The light will be diffracted like this in all possible directions, right? And again, a pattern will be formed over here on the screen, which is also placed at a very large distance, है ना? So this object is also placed at a very large distance. So D1 is also very large and D2 is also very large. Okay. So this type of diffraction is easier to analyze as compared to Fresnel's diffraction, because here the wavefront will be like this, right? A spherical wavefront will be falling over the disk. Here in this case, a plane wavefront will be falling over the disk. So here analyzing it is easier as compared to this. Is it clear, guys? In your syllabus you have only Fraunhofer's diffraction, so we'll understand Fraunhofer's diffraction by a single slit source. Okay, is it clear? Shall we start? ऐसा मैं लिख देता हूँ पहले नोट करके. अच्छा, generally the question comes in people's mind कि sir, if these distances are very very large, then how will you perform it in a lab? है ना? Only Fraunhofer's diffraction is there in the syllabus, and when we perform Fraunhofer's diffraction, we need to use two convex lenses of different focal length, right? So basically, what can I do in this particular case, guys? See over here, of different focal length. So you'll understand, see how exactly I'll do Fraunhofer's diffraction, है ना? जरा गौर से देखना. Suppose this is the single slit plane, है ना? Guys, this is a single slit, very small as compared to the this thing. This is where I have a screen. Let me draw a screen. Okay, this is my screen, and let's say this is my source. I don't want everything to be at infinite distance. If everything will be at infinite distance, will I be able to perform the whole experiment? Yes or no? Will I be able to perform the whole experiment?
No, sir.
No. So basically, to achieve Fraunhofer diffraction in lab, I use two convex lenses. Use two convex lenses of different focal length. First convex lens, I'll place it over here in such a way. Can you see, guys? First convex lens, let's say it has the focal length f1. I'll place it in near the source, in between the single slit and the source, in such a way that source lies on the focus. Guys, are you understanding this particular thing? I'll place it in such a way that the source lies on the focus of this particular thing. What will happen when light will go through this particular source? What will happen when light will go through this particular source? After refraction, they will become parallel, right? And this is what I wanted, if you remember. Yes or no? So can you understand the where exactly the first thing is placed? Guys, can you understand where is the first lens placed? Shall I write it over here? First lens is just placed between source and single slit plane, such that source lies at the principal focus of the lens. By doing that, what will happen? You will convert these spherical wavefronts which were coming from this particular source to plane wavefront. Yes or no? This is the first condition. So can you see? I achieved the incident plane wavefronts. Now what will happen? Sir, these light rays will get affected and form a pattern on the screen, but this thing is very large. So basically, what will I do? I'll place another lens which is just touching the slit. Guys, can you see over here? This another convex lens over here. Can everyone see another focal length over here? Another convex lens over here. एक second guys, ये छोटा हो गया. Yes. So can you see, guys? There is another lens which is just placed. So the second lens is placed just touching the slit plane, such that the screen lies in the focal plane of the second lens. So basically, whatever light rays which were falling on this particular thing, you will do, see, basically what did you do? Use the thin lens. So whatever distances which are coming from here, you will assume that they are coming from the optical center of the second lens, and you will place it in such a way that this thing is equals to the second wavelength. This screen lies in the focal plane. So basically, whatever light rays which will be falling over here, after refraction, they will become parallel, and they'll form an image over here. Are you getting my point, guys? Is it clear? Oh, sorry. Whatever light rays which were, you know, parallel in this case, so they will all meet at this point. like this, something like this. You understood, guys? So by just planing, by placing these lenses, f1 and f2, you achieved, Fraunhofer's diffraction in the lab. Is it clear? So this is how it is actually conducted. Okay. अब now for simplicity, अब whenever I'll analyze it, I won't draw these two lenses, but they are always present over there, है ना? ध्यान रखना. चलो. Guys, shall we start analysis of diffraction by single slit? Whenever you're done writing, just tell me. We'll start analyzing this thing. Guys, shall we start with the analysis now? Guys, shall I start? So please write down analysis of Fraunhofer's diffraction basically through a single slit. Now guys, suppose I have a light source, and let me assume there are the light rays are parallel on this. I'm not drawing the whole diagram. ऐसे वैसे ही काम चला वो diagram बना. Is it fine? So the incident light are basically parallel to each other, or basically you can say the incident wavefront are plane wavefront. So this is the case, है ना? Now let us say this distance. Can you see this distance? The slit. This distance. Let me assume this is, or in your NCERT textbook, it's given by A. Where what is A? A is basically the width of the slit. Is this clear, guys? A is basically what? The width of the slit. Now what will happen? This point, there will be many point source over here, which will be producing light rays in this, and every possible direction, right? In every possible direction, right? So basically, let us assume only that ray. Let us assume only this ray, which is at an angle theta. Okay? Let's assume only those rays which are at an angle theta with the horizontal, suppose. Is this clear, guys? So basically you will assume only these rays which are at an angle theta. You will generalize it for only these rays which are at an angle theta. So here in the case of diffraction, you obtain intensity as a function of this value theta. If I zoom in to this slit, If I talk about the magnified view of the small slit, so if I give you the magnified view, will it look like something like this? एक second ना. Will it look like this, guys? If I this distance is equal to a, if I zoom in to the where the slit is, will it look like this? And can you see the light rays? They are coming, still coming parallel to this particular thing, and illuminating this particular slit, right? So the plane incident wavefronts will illuminate this slit by a single wavefront, by a single wavefront. So guys, let us assume this is the wavefront which gets incidented. Let me draw it, है ना, please. Let us say this is the wavefront which gets illuminated, right? Yes or no, guys? Now can you see this part of the wavefront will get blocked, this part of the wavefront will get blocked, only this part, the one which is in the middle will be remaining, right? So control C and control V. Let me make it smaller. And so guys, can you see only this waves, this wavefront, only this much part, gets, you know, uh, forwarded. Remaining of the wavefront gets blocked, right? Yes or no, guys? इतना समझ में आया थोड़ा बहुत? People, yes or no? Did you understand this much part? कि only this much part of the wavefront moves forward. Rest remaining every part gets blocked, right?
Yes, sir.
Now see this particular thing. On this wavefront, I can assume many sources, many secondary sources, right? Can I assume many secondary sources over here? जैसे ये the one which is over here, 2, 3, 4, and so on, n minus 1. Are you getting my point? So can you see 1, 2, 3, 4? This is, let's say, n. This is n minus 1, and so on, है ना? So basically, what is happening? All these secondary sources, they will be producing wavelets in all possible directions, right? I am only considering those waves. I am only considering those waves which are at an angle, which are at an angle theta. I am only considering those waves which are at an angle theta. Why? Because I want to all of these light rays are at an angle of theta. Are you getting my point, guys? Yes or no? So basically what I can do, let us consider there are n secondary sources formed on the part of incident wavefront which is passing through the slit, right? So I assumed how many n secondary sources over here. Is it clear, guys? You understood this particular thing? I considered n secondary sources. Guys, is it clear? Hello, hello. So basically what I did, I consider there are n secondary sources And if the distance between each source is small d, if I say the distance between them is small d, if I say the distance between them is small d, distance between them is small d, distance between them is small d, so can you see guys what will be the relation? How many such n minus pair will be formed? Suppose there are three sources, 1, 2 and 3. So this distance will be d, this distance will be d. So can you see over here, this slit width d, slit width a is basically equals to twice of d, yes or no? So when you assumed three sources, a was equals to 2d. When you assume 1, 2, 3, 4 sources, then can you see d, d and d? तो यहाँ पे this distance between 1 and 4 is basically equals to a, तो क्या है यहाँ पे? Can you see a equals to 3d? Yes or no? Guys, are you understanding this particular thing, what I'm trying to do? If I say the distance between each source is d, then if I assume n sources over here, so can you see a relation? A is basically equals to whatever n will be there, so n minus 1 into d, right? Yes or no, guys? You understanding this particular thing? If I assume the number of sources to be this much, let me delete it, please. So guys, what is this 1, 2 and 3 and 4? What is this 1, 2 and 3 and 4? These are the number of secondary sources, है ना? ये दिख रहा है 1, 2, 3, 4 and all. So basically this is the number of secondary sources. So if there are n sources over here, here a is basically equals to 3d when there were 4 sources. A was equals to 2d when there were 3 sources. So if there will be 1, 2, 3 dot 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 till n minus 1 and then n. So if the distance between all of them is d, d, d and d, then this whole distance is basically equals to a. तो यहाँ पे write a equals to n minus 1 into d. इतना क्लियर है? a is equals to n minus 1 d का लॉजिक समझ में आया सबको?
Yes, sir.
कि एक बार फिर से समझाऊं कि it's fine? Okay, so a equals to n minus 1 d. Now we will consider only those rays, और रेस की जगह पे वेव्स कर देता हूं, only those waves from the secondary sources which are at an angle theta with horizontal, and the resultant intensity formed on a screen at any given point P will be because of superposition of these waves. So basically guys, do you remember in this particular case, all these rays, this is your I1, this is your I2, this is your I3, matlab all these waves are different intensity or whatever it is. the resultant of these thing is basically forming an forming a thing on the forming the resultant intensity on the point P, right? This is microscopic wave, है ना? Please remember, this is very microscopic wave which we are talking. कितना clear है? So basically, what did we assume? There would be many secondary sources in between the slit, and only those direction of waves taken which are at an angle theta from the axis. ठीक है? Is this clear, guys? Guys, is this much clear?
So,
हाँ जी.
Yes, sir.
तो अब सपोज करो if I talk about in direction theta, if we calculate the path differences between various waves. For example, guys, do you remember this question? The whole thing is becoming like this now.
So,
Anji,
so can you please scroll up?
sure.
Okay, sir, done, sir.
One, two, three, four. This is n minus 1. This is n. All these rays which are there are at an angle theta. Okay. Your diagram, I think it's clear, right? Shall I explain it? It's fine. All of these angles are theta, right? The angles, ye theta. Is it clear? Guys, is it clear?
yes, sir.
Okay. Now, suppose if I talk about the path difference between waves from 1 and 2. So basically, 1 is over here, 2 is over here. What is the distance between 1 and 2? Is it equals to B? Or is it equals to D? Guys, is this distance equals to D? I told you, no? If the distance between each secondary source is D. Hello? So 1 or 2 के बीच का जो distance है, it is D. And if I am assuming this angle to be, these are the two waves. So can I just draw this thing, a perpendicular from 1 to 2? Guys, can I do this? Can I drop a perpendicular from 1 on 2? Yes or no? Can I do it like this? Yes or no? Guys, if you remember, if this angle is theta, then this angle will also be theta. If this angle is theta, then what is this? This is basically the path difference between 1 and 2, right? Yes or no? Yes or no, guys? This is our wave 1, this is our wave 2. I'm just considering only this much part. Is it clear? So here the path difference between 1 and 2 will be equals to D into sine theta. If you remember, it is the same triangle, and you can do the same D sine theta, the one which we used in interference, right? So D sine theta. So if path difference is this much, then the phase difference between 1 and 2 will be equals to what? 2 pi by lambda into delta x12, which is basically equals to 2 pi by lambda into D sine theta. Right? Yes or no, guys? Yes or no? Is it clear, guys?
Yes, sir.
Let us assume this is equals to 5. Say this 5 and 2 is basically equals to 5. Now check for the path difference between path difference between waves from 1 and 3. Now basically I want what is the path difference between 1 and 3. If I talk about that, then can you see I'll draw this. 1 will be over here, 2 will be over here, 3 will be over here. The light ray from 1 will be going like this and 3 will be going like this. Now what is the distance, guys, between 1 and 3? This distance was d, this distance was d. So basically the distance between 1 and 3 is basically 2d, right? Yes or no, guys? Hello guys, थोड़ा बहुत समझ में आ रहा है क्या?
Yes, sir.
Yes,
So
sir.
basically again I'll draw a perpendicular over there, and if I say what about this particular thing, is this the path difference between 1 and 3? And I can calculate this 1 and 3. Delta x between 1 and 3 is basically equals to 2d sine theta, right? It was d sine theta, so now the distance between 1 and 3 has become 2d sine theta, right? Is this clear? So if I calculate the phase difference between 1 and 3, it will be equals to 2 pi by lambda into 2d sine theta. And you can see over here, this 2 pi by lambda into sine theta was basically, you said it to be phi. So here this thing will become 2 phi. Are you getting my point, guys? What exactly is happening? If you calculate the
Yeah.
path difference between 1 and 2, you got phi. If you calculate the path difference between waves from 1 and 3, you got 2 phi. If you will do between 1 and 4, then it will become, this distance will become 3 times of d, and this phase difference will come 3 times of phi, right? So if I try to generalize on generalizing path difference between the waves from 1 and nth secondary source, so it will become like this: 1, 2 and 3 and so on. This will become n. Can you see, when it was 1 and 3, it was 2d. So when it was 1 and n, it will be n minus 1 into d. And what is n minus 1 into d, guys? This is equals to a, right? Yes or no? The slit
Yes,
width,
sir.
the slit width is basically this. So if I generalize the part difference between 1 and n, it will become n minus 1 into d sine theta, and the phase difference between 1 and n will be basically n minus 1 times of phi. This is how I generalize it. Is it clear? Is it clear, guys?
Yes, sir.
Now,
Yes, sir.
if I say, if equation of a wave 1 is given by, if equation of wave 1 is given by y1 equals to a1 sine of omega t, then if the equation a1 is basically what, acha ha, since they all are with the same source, can I say the amplitude is same? Amplitude of all the waves, all waves from secondary source will be equal. Will they be equal? Because since it is the same source, same wavefront, everything is same, right? But can you see over here, guys, each of these small secondary sources, when we talk about the light ray, if wave 1 is given by this, then the equation of wave 2 will be given by a sine of omega t minus phi. Y माइनस, अभी मैं रीजन बताऊंगा, है ना? कैन यू सी द फेज डिफरेंस बिटवीन 1 and 3 is 2 phi. The phase difference between 1 and n is basically, guys, can you see there is a minor phase difference of minus? Why the phase difference of minus is over here? Can you see, guys, the wave from 2 will reach at point P later, right? Because it is traveling a greater distance, the speed is same, So time taken will be less, or basically can I say it will reach it will lag behind a part difference of this much, right? Anna, please remember, wave 2 will lag behind wave 1 by a phase difference of phi. Similarly, wave 3 will lag behind wave 1 by a phase difference of 2 phi, and similarly ये जो lag करेगा वो n-1 lag करेगा. तो is this clear, guys? The equations, are they clear? If the equations are clear, then can you see over here, by principle of superposition, if I try to find out the resultant wave is basically the sum of individual displacements created. So basically what will I do? I'll just add all of these together. When I'll add all of these together, it will become like a sine omega t plus a sine of omega t minus phi plus a sine of omega t minus 2 phi plus a sine of omega t minus n minus 1 phi. Is this clear? So when you know apply maths in it and solve it, I don't have the simplification. On solving this, we get, you don't need to remember this, na? Don't worry. On solving this, we get yr, the resultant intensity, is equal to a sine of n phi by 2 divided by sine of phi by 2 into sine of omega t minus n minus 1 by 2 into phi. So guys, can you see over here, this thing is, let's say, theta, and this thing is basically the resultant amplitude. So you can say yr is equals to r of sine of omega t minus theta. So guys, can you see this is the equation of what? Again, the same wave, right? You don't need to remember this. Don't remember this. You need to just see over here, the resultant amplitude is basically of the form of this. It's dependent on phi, it's dependent on the phase difference, it's dependent on the number of sources as well, right? So this is the whole equation which is found. And if you try to find out what is the intensity over here, so the intensity ka formula, if I try to apply the intensity ka formula, if I try to apply it, it becomes equals to k times of uh, k जाने दो, it is equals to I naught into sine square beta upon beta square. I'm just writing the formula. If you want, you can remember this, no problem. On solving for intensities, resultant intensity at point P on screen, IR is equals to I naught into sine square beta upon beta square, where beta is equal to n by 2 into phi. No need to remember the this formulas and all. कभी कर सकते हो तो it's well and good. नहीं कर सकते तो no problem. Into d sin theta, and यहाँ से when you'll solve, 2 से 2 will get cancelled. It will become almost approximate to Guys, can you see over here? From here it becomes n times of d into pi into sine theta by lambda. Can you see from here beta is basically this much? Yes or no? But you remember b was equals to n minus 1 into d, and we know this particular thing that it's a hypothetical concept, the number of secondary sources, तो ये बहुत ज़्यादा होगा 1 से. So we know n is much greater than 1, so you can approximate b is approximately equal to n times of d as well. So यहाँ से n times of d को you can write b नहीं, sorry, this was a, right? मैं एक बार फिर से समझा दूंगा, don't worry, I'll explain you from. हाँ, तो आई गेस गाइज यहाँ तक सबको समझ में आ गया होगा. Guys, I am assuming you people understood till the phase difference thingy, right? I am assuming you people have understood it from till here. Okay, shall I go up? Hello? Hello guys, hello.
Yes, sir.
Did you understood till here? ये phase difference तक सबको समझ में आता है? Equation making, everyone understood till equation making?
Yes, sir.
Yes, sir.
After this, what did we do? We just added all of them just by the principle of superposition. We know this particular thing, na? Yr is equals to y1 plus y2. So basically we added all the displacements. When we added all the displacement and solved, we got this function, which can be written in the form of yr equals to r sine omega t minus theta, where theta is basically the initial phase of the resultant equation and r is the resultant amplitude. Are you getting my point? So this whole function, I told you, on solving you can get it in this form. It means that it is a normal way which you generally derive. The resultant is something else, the initial angle is something else, but ultimately you get the overall equation the same thing. After this, on further solving it in terms of intensity, you get the resultant intensity is equals to I naught into sine square beta upon beta square, where beta is equals to a pi sine theta by ये lambda है. This is lambda. A pi sine theta by lambda, right? So ये एक result है. This is the formula for intensity. So can you see over here, beta is a function of theta and I naught is a function of beta. So can I say this particular thing that intensity, the resultant intensity is basically a function of theta? Can I say this? Guys, can I say this? The resultant intensity, you can say on generalizing, the resultant intensity is basically a function of theta, and that is what we wanted to prove कि जो intensity है it will vary with theta. Is it clear? ये सिर्फ direct formulas I have given, I have not solved them. Is it clear guys? आपके school syllabus में you will be having till here, and even not till here also, they will just give you the wave from the part difference between the waves is basically this much, and the waves के बीच का they will give you like this, right? So now let's see guys, what is the central maxima due to where is the minima and where is the maxima which is found. Okay. Now conditions that at point P we get first minima. So I'm talking about the condition where we get on the first point P we get what? A minima. slit width is equal to n and this angle is theta, right? So guys, I want what is the condition for minima at particular point 0. We know that particular thing at minima, at whether it is first minima or second minima or anything, at minima the resultant intensity should be 0. Yes or no? Yes or no, guys?
Yes, sir.
The resultant intensity is 0. Acha, if I show you a microscopic view of this particular thing, then will it look like this? This is basically the first point and this is basically the end point. This distance is equal to a, and I'm assuming, let's say, this distance a, the slit width a is equals to n lambda. Okay, so basically I'm assuming how many points? N plus 1 points, है ना? So if I'm assuming n plus 1 points, then how many it will be there? एक second रुक जाओ guys, एक minute, just wait for 1 second. Let me check the derivation which is there given in your school notebook, है ना? NCRT wave optics. One second guys, है ना? तो पोलराइजेशन स्टार्ट हो गया भाई, एक सेकंड बंद कर दे माइक माइक. So basically what have they said this particular thing? Let's say these point, in spite of naming it one and चलो मैं वैसे ही करता हूँ. Let's say this point is A and let's say this point is B, है ना? Hello guys, and I'm saying that AB को assume it to be equals to n lambda, right? Let AB is equals to n lambda. When it is equals to n lambda, now let's see what will happen. Okay, so if I talk about the path difference between two waves, let's say this is your first wave and this is your n plus 1th wave, जाने दो, अपने को उससे मतलब नहीं है अभी. So this angle is also theta, this angle is also theta, this distance is a. If I drop a perpendicular again, can you see what is the difference, part difference between the waves from 1 and AB, so let's say A and B are the initial and the final secondary source. The path difference between A waves from A and wave from B is. So guys, can you see over here, if I want the path difference between from A, this thing, then will it be equals to this distance, this the path difference between A and B, right? Yes or no? So the path difference between A and B is equals to A sine theta. Is it clear guys? Is it clear guys? इतना समझ में आया? For minima, let this path difference the school derivation, for minima, let's say the path difference between A and B is basically n. Okay, so guys, ये थोड़ा सा ध्यान से देखना है ना. Delta x AB, I'm assuming it to be equals to n lambda. Is it clear? I'm assuming what the path difference between the first wave and the last wave is basically equals to n times of lambda, where n is what? Where n is what? And so on. N is basically 1, 2, 3, 4, and so on. This is a number. It's just a general number, not the number of wavelets over here. Guys, hello? N is just an integer. Please remember here, n is not the number of sources, secondary sources. N is just a number from 1 to n. So if I want for what is for the first minima, this n की value is equals to 1. School derivation I'm giving, है ना? School में they have given it just like this. So for n equals to 1, I'll write it delta x AB will be equals to what? Lambda. Right? Delta x AB will be equals to lambda, so I can write it like this. Can I write it like this? Sine. Hello people. Guys, इतना आपको समझ में आया क्या? Did you understand till here? Mike.
Yes, sir.
Yes, sir.
So delta x AB is basically a sin theta. समझ में आ गया? ये समझ में आया कि हम for minima I'm giving you the condition. For minima, what is the condition? The path difference between the first wave and the last wave should be equals to n lambda, where n, इसको n मत लिखो, अब m लिख लो. If you get confused, m, let's make m as the order, right? So here m is basically the order of the maxima. Just to avoid confusion, I'm changing the letter. Order of minima. Is it clear? So for first minima, m will be equals to 1. For second minima, m will be equals to 2. For third minima, m will be equals to 3. Is it clear? आप समझ में आ रहा है इतना कुछ? Now I'll just put this m lambda over here. So m lambda is equals to a sine theta, and from here, can you see sine theta is equals to m lambda upon a? Yes? Yes or no? And can you see from here, theta is equals to m lambda sine inverse of m lambda by this is basically the angular position of mth minima. This is the angular position of mth minima. ठीक है? इतना समझ में आया guys?
Yes, sir.
ठीक है. This is the derivation which is given in your school notebooks, है ना? कि for minima this is there, and for maxima तो इसमें count नहीं करेंगे. Maxima will just calculate the angular position and all. So angular position of mth minima is this. Special case, if theta is very small, which it will not happen generally. If theta is very small, then you can say sine theta is approximately equal to theta in radians. And from here, you can directly write theta is equals to m lambda by. ठीक है? But this will only happen when theta is very small. Is it clear? इतना clear है guys? These are the main results. M cannot be equal to 0. Always remember this thing. M is always starting from first. So for M equals to 1, that is basically the first minima or first dark. I'll get the angular position of the first dark, right? So if I say this is my screen, this is my single slit, and what is the width of the single slit? Let's say A, the wavelength of the light is lambda, then at what angle will I get the first minima? If I say theta 1 dark, the theta 1 dark is equals to sine inverse of m की जगह पे 1 डालूंगा, so it will become lambda by. Yes, is this clear, guys? This
Yes, sir.
is the angular position of first maximum, first minimum. Acha, same first dark will be formed on the bottom of the pattern as well, right? So this will be also your first dark. So guys, can you see ये यहाँ से यहाँ तक, यहाँ से यहाँ तक, you can see this thing. The first dark is lying at this point. So basically here in this case, hello guys, can you hear me?
Yes, sir.
I'll face a little bit of connection issue. Let me just reshare the screen again. हाँ कर दिया. So guys, you can see at this position, this angular position theta 1d, you will get your first dark above the central, this point O, and at the same angle below the point O, you will get the same first dark, right? Yes or no? So basically, can you see over here, from here till the point where there was no first dark, this whole thing is basically the central bright which is formed. So can you see from here to here, this till 2 theta angle. So if someone asks, note the central bright exists till the occurrence of first dark or first minima, right? So if someone says ki what is the angular width of central maxima, if someone says ki what is the angular width of the central maxima, then our answer should be is equals to twice of theta 1 into dark. Is it clear? Which is basically twice of sine inverse of lambda by b. Is it clear, guys? First dark clear है सबको? Guys, is it clear? Abhi don't worry about the intensities and all. Abhi I'll show you a diagram in which there is what is the diffraction pattern and what is the interference pattern. मैं दोनों clear करूँगा YouTube में video दिखा के. Is the time over?
Sir?
हाँ जी.
Sir, is it A or B?
It is A बेटा. वो मेरे दिमाग में A चलता है ना, इसलिए lambda by A. There is nothing B in this thing है ना. There is A and D. D was basically the distance between the secondary sources and A is the slit width. ठीक है? So wherever if I
Okay, sir.
in गलती से कभी B लिख दिया हो, so you can correct that. So guys, this is the position of, this is your first minimum. And what will happen to the second minima, guys? For m equals to 2, you will get the angular position of the second dark. This will be equals to sine inverse of twice of lambda by A. Are you getting my point, guys? This is lambda by A for first minima. This will you will get for second minima, you will get this. Is it clear, guys? So यहाँ पे you don't define with the help of angle, है ना? Angle से भी करते हैं, we solve, if we know the angle, then I'll tell you how to solve, the questions and all. इतना clear है क्या?
Yes, sir.
So
Yes,
this
sir.
is what is there in your syllabus, and in the next class, it's a maxima for diffraction is not there in your syllabus. I have that, but I'll not give you that, है ना? कोई बात नहीं. Anyways, so in the next class we'll be completing diffraction and we'll be starting with the polarization. Diffraction is almost done. Almost done क्या है? खत्म ही हो गया. I just needed to explain you about the first minima, which was very important. थोड़ा बहुत और points दिखा दूंगा, and I'll show you the pattern, and I'll tell you about the resolving power as well. Resolving power, do you remember, guys? Resolving power I told you. Yes or no? Resolving power was not in ray optics. The resolving power was in wave optics.
Sir,
हाँ जी.
sir, why does the intensity of this keep decreasing from the center to
Intensity
maxima?
यहाँ पे decrease इसलिए करती है क्योंकि आप do you remember this function? ये दिख रहा है? Intensity is the function of theta.
Yes, sir.
And can you see theta is equals to, can you see beta is basically a function of theta. तो मुझे एक बात बता, suppose as इतना तुमको पता है ना कि in the case of diffraction pattern, as you go up the intensity will decrease, right?
Yes, sir.
So if theta decrease, if theta is increasing, beta will be increasing.
Yes, sir.
है ना, क्योंकि sin theta की value increase हो रही, तो beta will also increase. Yes, but can you see over
Yes,
here
sir.
this function sin square beta upon beta square. अब मुझे एक बात बता, whatever you increase the value of beta, you can increase the value of beta, but this sin square function will lie between 0 and 1 only.
Yes.
But
Yes, sir.
कभी suppose कर तू beta is it's very high. If beta is very high, then this denominator increases way far as compared to the numerator.
Yes,
So
sir.
overall, the resultant intensity decreases because theta is increased. When theta increases,
Okay, sir.
beta increases, but beta, when you increase it, denominator increases more as compared to numerator. So overall resultant intensity decreases.
Yes, sir. Understood.
Understood? ठीक है. Chalo, anyways, next class we'll write some more things about this thing, and we'll finish the diffraction and we'll start with polarization. ठीक है? कब है next class? Monday. Right? We have a next class on Monday, right? Yeah, nahi.
So Wednesday.
Next class we have it on Wednesday. Okay, ठीक है. ठीक है, guys. We'll see you again then on Wednesday. By next week, I'll be done with wave optics, and I'll be starting with modern physics. We'll start with photoelectric effect first, है ना? And please remember, modern physics is mostly chemistry. So whatever chapters I'll tell you from 11th grade, revise them, and then we'll discuss, है ना? I told you this
Okay,
particular
sir.
thing. No, your physics teacher becomes your chemistry teacher after in modern physics in 12th grade. है ना? तो अब वो chemistry पढ़ने का time आ गया है. So after wave optics, we'll start with understanding the whole modern physics. ठीक है? चलो, thank you very much, guys. We'll see you again in the next class.